Welcome everyone. In this 15-minute demo, you'll see how to improve your AI quality. TruEra Diagnostics helps data scientists with testing, debugging, and model explainability so that you get more models into production faster. Now here's the demo by Avinash.
Good morning, good afternoon, good evening, folks, based on which time zone you're in. Daniel just give you a quick overview of what contains TruEra as a product, and more specifically in our Diagnostics 2.0 launch. What I'm going to cover in the next few minutes is I'm going to showcase some of those features as a demo by taking a particular use case at hand. And the use case I'm choosing is the credit risk use case, a pretty common problem that most banks try to solve, where whenever someone applies for a loan, and there's someone who's judging whether the candidate that's applying for a loan is a high risk candidate who would probably default on the loan or not. Before, it used to happen, humans used to do it. Now the machine learning models have taken over, and this use case is about that one such model, where a model has been built by taking features in such as interest rates, loan tenure, debt to income ratio, the salary of the income of the applicant, etc. And a model then classifies that individual as a high risk or a low risk individual for the credit. What the approach that's going to be is, the model is trained. We're not going to be discussing about the training of the model, but we will be discussing the evaluation of that model using a set of features that TruEra provides. At the end of this, the number one goal is to help data scientists improve their credit risk model, but also do so such that they can build trust with their stakeholders. And then by increasing the accuracy of the model and the performance of the model, not just the accuracy, minimize the risk of borrowers defaulting. Now let me quickly jump into the demo by pulling up our UI. So before I talk a little more about the UI, TruEra has two parts to it. One is the web GUI that I'm going to be showing, and the other is a Python SDK. That SDK is what can be used through any of your usual IDEs, like your Jupyter Notebooks, Jupyter Lab, VS Code, PyCharm, or whatever new we come up with. And that's your primary way of interfacing your development environment with TruEra. Through that SDK, you can ingest your models, ingest your data into TruEra, or you can run TruEra computations locally as well, and then upload just the computations in case your models are too complex, and then use the web GUI to analyze them in depth. So in the interest of time, I've already ingested the models and data here. So we'll be doing the second part. So let me open up our project, which is the credit risk model testing. So as you can see, I have two models already ingested in this project. Both are XGBoost models, but they primarily vary in their hyperparameters. This model uses 25 estimators and depth of 4, while this model uses 100 estimators with a depth of 6. As you can see, at least on training a data set, the AUC on the bigger model, which is the 100 estimator model, is better. It has a 0.95 AUC, while the smaller model had only 0.82. So on paper, this model looks good, but this is only on the training data set. You obviously want to test this on a validation data set. So I'm going to pull up a model summary of this particular model. The model summary quickly shows me two things. One is up top, it shows me the metadata of this model. When was it created, or rather when it was ingested with TruEra, what data was it trained on, how many features were used to train this model, etc., and if you have captured any notes. And secondly, and more importantly, it gives me an aggregate test results for this model. It shows that there are two failed tests. Now, at this point, you might be thinking, what are these tests? How did we define this test, etc.? Let me show you that. So, what a test looks like. So, a test with the test harness can be defined using the Python SDK. In the future release, we'll also have a UI for this, where you can add a performance test by using our SDK's tester workspace, where you can give which data should the model be tested on, what metric to compute, give a warning threshold and a failure threshold. Now these thresholds can be as complicated as you want them to be. So this can be an absolute threshold which says anytime a model gives me an AUC less than 0.85, give me a warning. If it's less than 0.8, fail the test. Or it could be a relative test where you can say that anytime a model gives me an AUC of less than 5% from my training set, fail this test. Or you can also create a relative test based between two models instead of two splits. Till now, I've been talking about train versus test, which are both data sets. You can also do it between model 1 and model 2, where a newer model should always have better accuracy than my previous model, for example. So test harness lets you create all these kinds of tests. Or I'm just showing you an example of performance-based tests, but we have drift-based tests, we have fairness-based tests, all the different analytics that Daniel was referring to. You can define a test for all of those. But for simplicity's sake, let's continue with the performance test. So I see for this model, we are failing a test on the validation data, where we're getting an accuracy of 0.761. Now I want to debug this further, right? Like identifying the problem is just step one. Then you need to figure out what to do to fix this. That's when the comprehensive set of analytics that TruEra provides come into the picture. Where now I can go into the performance page of this model on this data set and try to see what's going on here. So clearly you can see that there's a drop in accuracy. AUC is 0.95. On the validation data, it's 0.76. You can look at the different curves that the typical classification visualizations you would look at, like the ROC curve, the precision recall curve, the confusion matrix, etc. But here is where the differentiation comes with TruEra. TruEra allows you to generate what we call high error segments. High error segments are nothing but a way of finding a region in that data set where the model is especially bad, which is bringing down your overall accuracy. So in this case, I'm trying to generate high error segments on this model, and this will then pop into the segments page to analyze it further. So this automatically generated high error segments is showing me that for when interest rates are above 0.156, I don't know whether you guys can see it, but whenever you have interest rates above 0.156, your model seems to be doing especially poorly. So if you compare these two segments, which is when interest rate is just above 0.156, our AEC is 0.69, while for the rest of the population, it's 0.74. That's almost a 5%, 4.2% drop in accuracy, just because of a particular set of points in your data set. You can go further and then try to see how is the feature influence changing in this segment when compared to the rest of the data. Excuse me. I can pull up what we call an influence sensitivity plot for a particular feature and see how is the influence of this feature changing as the feature value changes. So as you can see here, as the feature value changes, which means when the interest rate is increasing, the influence seems to be towards moving it toward high credit risk because it's going up. But clearly something is going on with the high interest rate segments because the error rate keeps going up as the interest rate goes up as well. So if in this segment, the high interest segment, the error rate is much higher when compared to the rest of the population. There's a clear indication that something is off about this region of the data. In this analysis, all I was doing was looking at the validation data in particular. It should also, what we saw there was that there's a difference in accuracy between the training data and the validation data. For that, I would jump into the stability page of TruEra, which allows me to compare a particular model on two data sets. So I'm going to continue my base split to be the validation data and change my compare split to be the training data. So as soon as you do that, you can clearly see that for validation data, the model seems to be giving higher scores when compared to the training data, which means it seems to be finding more high credit risk predictions, or rather it's predicting more high credit risks in the validation dataset when compared to the training dataset. Again, we can see how is the feature influence for this particular feature, the interest rate, changing between these two splits by pulling up the ISP plot again. Now, when I pull up the ISP plot, I can the pattern remains similar for both the data sets, both for validation data and training data. The pattern seems to be that as the interest rate increases, the credit risk seems to be going up. But if you see, we seem to have a lot more of validation data in the high interest rate segments when compared to the training data. We see in this region, there's a lot more green than yellow, which tells me that excuse me, which tells me that this data is not balanced, at least for the high interest rate segment. We have a lot more points of high interest rate segment in the validation data, but we have far fewer points, at least percentage wise, in the training data, which is why the model is not able, hasn't learned the right pattern for the high interest rate segments. It's erring towards just giving a positive result, a high risk prediction for whenever it's not able to figure out what this, how to classify a point. This clearly gives you a next step now where you can rebalance your data, training and test data, or go and sample more data or find more data for high interest rate segments. This is a much better approach to debugging and improving your model than how you would usually do, where you would try to throw more data at it or do hyperparameter tuning. I've been there where I've tried to just change the model. Maybe a more complex model would work, like maybe throw neural networks at it. But all of those are just throwing a bunch of darts at a dartboard and trying to see whether it fits, instead of having a more targeted approach over what your next model iteration should be. TruEra provides that for you. So step one, identify the problem using the test harness. Localize that quickly by figuring out, hey, there is high interest. This issue exists with high interest rate segments. Some segment of the data. In this case, it turns out to be the high interest rate segment. And then debug it further by trying to use the different tools that TruEra provides. Now, to finish the swing on this, now that you have found an insightful next step, you need to log it and you need to create a report out of it. TruEra allows you to do that with a click of a button. You can just click the create stability report and give it a quick name. Credit risk webinar demo, and then click on create new stability report. This automatically captures whatever choices you have made, whatever analysis you had done into a report format, and allows you to annotate this report by giving your own notes. So you might, if you want to put in notes for maybe less technical users who might not understand each of these visualizations, but can understand what a more business language. You can write it down in your business language terms, where you can say high interest rate applications tend to falter in this model, with this model. Or for your data science, for your colleagues, you can always say that rebalancing of data is what is needed as the next step. And then you can export this as a report, which it will download this in an editable Word format for you, which you can then share with anybody outside of who might not even have access to TruEra, or put this report along with your model when you're pushing this to production. So this will instill more confidence in your stakeholders, and also people handling your production deployments, because they know what are the different tests you have ran, what are the different analysis you have done, and why you think that this model is ready for production. Right, so that's the demo. And just to recap what we just discussed, these were the 3 steps, right? We first did model testing, where we ran a bunch of tests to figure out where the issue was. Then did interactive debugging by using different tools that we had in TruEra, by quickly identifying the issue, localizing it, investigating the root cause. Then once you have the root cause, figuring out what are the next steps should be. And then finally reporting this in a customized reporting format which you can then tailor for your specific use case by adding your own comments, etc. Finally, once the model is in production, unfortunately, we don't have time today to go into monitoring, but TruEra also provides a tool for monitoring your models that are there in production, and has a good and links back to your diagnostics. So whenever there's an issue found in while monitoring a model in production, you can bring it back to your diagnostics product and then debug it further and then redeploy the next version. And that's the demo. Thank you so much.